This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
At Collide, we know end users are IT admins' most significant untapped resources and key to solving the most challenging to fix security issues, including instructing developers to set passphrases on unencrypted SSH keys, finding plain text two-factor backup codes and teaching end users how to store them securely, convincing employees to uninstall evil browser extensions that may sell their browser history. Visit collide.com/SERadio to sign up today. That's KOLIDE.com/SERadio. Enter your email when prompted to receive your free Collide gift bundle after trial activation. You can try Collide with all its features on an unlimited number of devices for free for 14 days. No credit card required. Try it out at collide.com/SERadio.
Hi, this is Philip Winston for Software Engineering Radio. I'm here with Sergey Gorbunov. Sergey is a co-founder of Axelar and an assistant professor at the University of Waterloo. He was previously a founding team member at Algorand. He received his PhD from MIT, where he was a Microsoft PhD fellow. His PhD dissertation was on designing cryptographic tools for the cloud using lattice-based cryptography. Sergey, is there anything I left out of your bio you'd like to add?
No, I think that pretty much sums it up. Thanks, Phil, and great to be here.
Great. Before we start, here are two shows from our archives that I found helpful in researching this topic. Episode 297, Kieran James Lubin on blockchain, and episode 343, John Crane on Ethereum and smart contracts. So starting from the top, what is blockchain interoperability?
Yeah, so on a very high level, what we're seeing in the blockchain ecosystem today is that many different networks being built, right? Many different blockchains. So you have networks such as Bitcoin, such as Ethereum, Algorand, Cosmos, Polkadot, Near, and the list goes on and goes on. And so blockchain interoperability at the very core is the concept of how do we connect all of these blockchain systems together and allow connectivity between applications and users at the very end of the day. Today, that's not really possible in many instances. And blockchain interoperability and what we're trying to solve is precisely that.
Okay. Do we know how many blockchains are there or how many sort of major blockchains are there? And which ones do you expect users will want to interoperate between, or is it just any interoperating between any blockchain?
Yeah, so I think today there is definitely higher number of dozens of blockchains that have good usage and good use cases, right? So maybe 30 to 50. There are thousands of blockchains on their own. Many of them are smaller blockchains still today, but they continue to grow and continue to get use cases and continue to get tractions. I do expect we're going to see thousands of big blockchains down the line in the years. And I think the reason for this is, similar to if you look at the history of the internet of how it evolved, right? And you see very similar properties as we see, in the blockchain system today. We started with dozens of networks, then it went to hundreds, then it went to thousands. Many of them kind of optimized for specific applications or specific needs of their user base or demographics. And I think we're starting to see a lot of the early signs and a lot of the same momentum happen in the blockchain systems today.
Okay, one thing I wasn't clear about, I know cryptocurrency is only one use of blockchains, but today I assume I can exchange cryptocurrency from one type to another. So if I have Ether and I want to use a service that's on Solana, presumably I can exchange between those two. Is that not a form of interoperability, or are we talking about something more pervasive or more deep than that?
Yeah, I think exchanging of value through a centralized provider, right, through an exchange is actually a form of interoperability, right? And the centralized exchanges to date, they've been actually the only interoperable systems that have scaled, right? You take an asset on one chain, you swap it for an asset on the other chain. Now, I think we're in a pretty exciting space in the blockchain system where we're actually starting to see interesting applications being built, right? Decentralized applications, Web3, open finance, NFTs, and so on and so forth. And so for those applications to interoperate and allow them to do their functions, and some of them could be as simple as swapping an asset from chain A to a chain B, or some of them take a loan against my asset. But those are inherently decentralized applications, right? And like to connect them together, we similarly need decentralized and open software stacks and a technology to do that. And so that's what interoperability is about, is like allowing these applications to continue growing, to continue being as scalable as some of the centralized applications like centralized exchanges, but without having to add friction and kind of concentration in the process of centralized parties.
Okay, yeah, we're definitely going to get more into applications in a little bit. One thing I wanted to also clarify is, I guess there's a series of documents called ERC, which is kind of like RFC is for the internet. I guess these are for Ethereum. And there's one called ERC 20. Can you explain a little bit what this is and how it relates maybe to the proliferation of different types of either blockchains or just of currencies on blockchains?
Yeah, no, it's a great question. I mean, one fundamental kind of use case of a blockchain system is to be able to create a new asset on top of it, right? So for instance, you want to create a tokenized version of land as property, right? So that's one type of asset. Or you want to build your own kind of governance token or digital coin that represents a business or an operation that you're trying to set up. So how can you do this? One way of doing it is to tell you, go and build your own chain from scratch, right? But that maybe, is not as simple if you're a one-man kind of developer that wants to have this asset being created like overnight in a couple of hours. So platforms like Ethereum and ERC20 ERC20 format are trying to solve this by allowing people to easily create their own sort of assets or forms of assets on top of existing blockchains, right? On top of Ethereum, like Avalanche, and you can go to other blockchains and do this. And you can do this, in 5 minutes by executing a couple command calls and a couple of function calls. And then you can define your own rules for this asset. Like how many of those assets do you want to mint? What are the transfer ownership rights? Who is the owner behind the asset? And you can kind of customize it as you need it for your own use case and application. And so the ERC20 format is, one example of an asset class that's easy to create, easy to use, and then you as a developer can integrate it in your application or kind of build a use case around it.
Okay, I think this might be related to, I've read about different layers for blockchains, different layers. Can you not necessarily go through all of them, but just kind of explain from an interoperability point of view, what layer are you interoperating at, or is it multiple layers?
Yeah, great question. I mean, I think on the high level, there's notion of like layer ones and layer twos, right? And I don't necessarily think they're, quite accurate in some sense. I mean, layer ones, I think, are pretty clear. And what is a layer one for everybody? It's, basically a blockchain. Okay, so you have a set of nodes. Those nodes execute a consensus protocol. The consensus protocol allows you to, write data into this distributed system and allows people to read data out of it, right? So that's like a layer one. Layer two is very similar in that model, but some of the properties of this distributed system may be inherited from other systems, right? So for instance, security of my chain could be inherited from a security of your chain, right? Through various mechanisms and like transfer rights and so on and so forth. And so that's what people refer to as layer two. But I think kind of for all practical purposes, it's a chain that's sort of instantiated differently somehow in the ecosystem. The way we think about interoperability, and in particular what we're doing at Axelar, is we're thinking of it as an overlay network that sits across multiple blockchains, right? So I think one example of overlay networks are players like Akamai, right? So for those that are familiar with a traditional, networking and infrastructure, sort of Akamai sits an overlay network that has their infrastructure built around different ISPs, and then it's, delivers service for the internet that allows people to efficiently deliver content from a source network to a destination network, right? And so similarly, we think of Axelar as a similar type of a service overlay network that spans across multiple blockchains. And there's a network layer, and on top of it, there is a SDK and an API layer that makes it easy to interact with the network, but it sort of sits, as a layer above that spans all of the other blockchains. So I don't know what number we want to give it, but I think that's a high level.
Yeah, it's interesting, the analogies with the internet or with networking. I guess in some sense, a blockchain is a network. You have nodes and you have connections. And like you say, you have then multiple networks and connections between networks. So it's interesting that this is new, but also referencing stuff that's come before. You mentioned consensus. The two shows I mentioned at the beginning have more details. We're not going to get into the full details, but are there many different types of consensus, and does that affect interoperability? I don't know if the proof of work and proof of stake, if those are considered consensus, or maybe those are incentive mechanisms, but just trying to get a lay of the landscape and what challenges it presents to you.
Fantastic question. Yeah, so there are many different types of consensus mechanisms, right? There is kind of Nakamoto proof of work consensus mechanism. There is Byzantine type of consensus mechanisms, right? Byzantine consensus is a kind of traditional consensus algorithm that has been used at least in academic literature for many decades, but finally started to find its way in the blockchain systems as well. It has been created in various shapes and forms, with various properties. There are newer consensus protocols that people have built, including the protocols behind Algorand, like Avalanche, and so on and so forth. So there are many consensus protocols. And back to your point, this is exactly what makes the interoperability as a challenging problem, right? You're not speaking with systems that have, the same interface or the same properties. You have to talk and translate from systems that speak very, different languages, have different formats of what is considered for a transaction to be final. Right? Maybe for Bitcoin chain, it's like, is this transaction 6 deep in the block, right? And that takes an hour. For other chains, maybe it's just a couple of seconds and you have instant finality. And then you have to translate the messages from one format to another and so on and so forth. And so, yeah, I think just the vast, array of different software stacks and consensus protocols people have built is what makes interoperability challenging, because you have to translate all of these things, in the process. And kind of back to your previous point about centralized exchanges being interoperable systems, you actually see, players like Coinbase take like 6 months to onboard another chain that has like very different rules, because like it's not a trivial task. But we have actually built kind of with Axelar a software stack and a platform that makes it super easy to onboard new chains, right? Regardless of the consensus mechanisms, like 10, 15 minutes through the platform you can run through, assuming it has, certain EVI and EVM support, and we're going to continue scaling from there. So that was really one of the core properties that we wanted to achieve, is that we want to keep on scaling. We want to be able to make those connections as easy as possible without having to, spend 6 months of engineering work to do that.
Sure. And I guess something that comes up a lot are the idea of a validator. Is that something that's common across all blockchains, or is even that dependent on the implementation, having validators or not?
I mean, some ecosystems call it differently. Some call them validators, some call them miners, right, in Bitcoin, because they're using a lot of processing power. But the notion, is pretty similar on its own, is that certain nodes in the system are allowed to, produce blocks, let's say that, right? And so in the Bitcoin networks, those are miners. In proof of stake networks, those are validators. And it is kind of what makes the consensus protocol sticks, right? There's special nodes that are actually running the underlying consensus mechanisms and reaching these finality goals.
Okay, so that gives me the sense that each blockchain is not totally from scratch unrelated to the other ones. There are similarities, but there are differences, which makes sense. So let's talk about programmability on blockchains. Was Ethereum the first programmable blockchain, or is it just the most well-known? And is programmable blockchain, is it for implementing just smart contracts, or are there other benefits to programmability?
Yeah, I mean, I think, actually Bitcoin was probably, the first programmable chain, but the programmability there was pretty limited, right? So you had a notion of a script, a Bitcoin script that you can write your logic in, but it's very limited. And I think Ethereum, I mean, I don't know all the roots behind how they came up with the design, but they said, well, how can we make it more generic so that we're not limiting the developers to kind of very special scripting functionalities, but we can make it, close to a full developable platform, right? It's close to like a Turing complete language where you can write any program and execute any function. And so indeed, sort of Ethereum was the first instantiation of that vision, where developers could write their arbitrary code in some sense, right? And execute complicated logic or simple logic kind of on top of the platform, and then the network of validators and miners in that case validates that logic and allows them to execute it in a distributed system.
Okay, we're going to linger on programmability just for a little bit since we are a software engineering show. I think it was the Ethereum yellow paper. I'm not sure if there's a white paper and a yellow paper, but I think the yellow paper had the machine codes or the opcodes, I guess, for a virtual machine, and it described them in detail. I was pretty interested to see that. How would a developer write software that runs on that virtual machine? I know, say, with C# or Java, you write in a higher level language. It gets compiled down to the virtual machine. Is that how it works with Ethereum or other blockchains?
Yeah, pretty similar, right? You have, Solidity, I think, is a common language that's used in the kind of Ethereum-based execution environments. And then developers write their code in Solidity. And then they take that code, they sort of compile it with a specific Solidity version that produces the bytecode. And then this bytecode is what gets actually deployed on the chain itself, right? And so, you do have to be careful in the process to make sure that you're compiling, using the right version of the compiler that the chain interprets and understands correctly, so that you don't then end up, faulty bytecode and so on and so forth. But yeah, I think, Solidity, I think, is actually pretty straightforward as a language to use. Kind of if you're familiar with, JavaScript or Python, like you get a grasp of Solidity, I think, pretty easily. That being said, you do have to be, very careful not to introduce security vulnerabilities, right? And we can talk about it, but I think that's what makes it challenging to, once you deploy your application, unless you put some type of upgrade logic, it becomes immutable on chain, right? So what that means is that the code is sort of fixed in. You can't just easily push an upgrade button if you find a vulnerability into it. You can work around it and you can put, an upgrade logic around it, but you're going to have to do that explicitly. But by default, the code is immutable, so you have to be extra careful to do audits, right? To find vulnerabilities before the code is deployed, to carefully check all the security conditions. Because once it's out there, it's run by a decentralized system, and you can't take it down.
Yeah, one detail I wondered about that is how many different nodes are potentially executing your same program. Is that, I assume there's a lot of redundancy there, but is that, dozens or hundreds of times, or is it cross-checked? Like, what's actually running your bytecode?
It depends on the blockchain. In some of them, it's depending on how many validators you have. So every validator would have to execute it. So if it's dozens of validators, then it's dozens. If it's hundreds of validators, then it's hundreds. In some systems, you have nodes that are also executing a similar bytecode, right? So there's a redundancy there as well. So yeah, I think that's sort of quite important in order to reach the consensus, right? Because you have a system that you're trying to execute in a decentralized environment, and your goal is to reach a consensus on the state of that system, even in the presence of malicious actors, right? So you can't trust a single person execute all the functions. You have to trust a decentralized sort of committee or validators to do that. That being said, there are ways to kind of simplify some of this. There are things like zero knowledge proofs, where you can, change the programming model a little bit and require only a smaller subset of validators to execute the logic. But by default, it is a large number of validators and some nodes that are executing all the logic.
Okay, so we talked about Ethereum sort of up the ante for the degree of programmability. Are blockchains that have come out since then sort of matching that level of programmability, or is it getting even more customizable? Like, what's kind of the direction for programmability? Have we already reached sort of maximum generic capability, or is it still evolving?
So programmability, I think, has been expanded on two levels. I think one of them is at the core blockchain level itself, right? So projects like Cosmos and Polkadot, for instance, they ask themselves the question, well, what if a developer doesn't just want to build a smart contract, but they want to customize the rules of the underlying blockchain, right? So for instance, customize the number of validators, or customize what the upgrade protocol should look like for the underlying network, right? So those are ability to program the network layer itself. And so projects like Cosmos or Polkadot, they allowed you to kind of program on a lower level than the underlying network and this distributed database. So that's one avenue of expansion. And many projects kind of have benefited and build their own software stacks, customize, number of validators, their programming environments, and so on and so forth. And then the second I think, programmability aspect is like what language do the developers actually interact with the system, right? And Solidity and Ethereum virtual machine are definitely examples. There are others. So there are people writing code in Rust. There are people kind of writing code in JavaScript. So for instance, Agoric, right? And so they build their own chain and with their own programming environment on top of it. And so the programmability on top of these blockchains, I think, continues expanded to support different languages and different frameworks. That being said, I think most of the chains today that have gained traction, there are kind of Solidity and Ethereum based outside of Ethereum, because that's what early developers were familiar with, and they know how to just take their code and kind of deploy it on a different chain and continue scaling from there. But I do expect to see, I think, more variety over the coming years.
Okay, let's talk about applications from the user's point of view for just a little bit, and then we'll dive into existing operability methods and then the Axelar network in particular. So can you give some examples of distributed applications that would be improved with better interoperability? So something that's maybe possible today but would be much easier, or something that's not possible today that would become possible if interoperability were sort of a solved problem or a easy thing for users to do?
Yeah, I mean, I think one example is to go back to this application of exchange, right? So, today we're starting to see early examples of DeFi applications that allow people to swap one token for another. So at its core, if you build one of these applications, let's say on an Ethereum chain, then the assets that you can allow users to swap are limited to these ERC20 tokens that are built on Ethereum, right? So you can't take an asset like Bitcoin and allow them to swap in your application. You can't take, an asset from a Cosmos chain and allow it to be swapped for an asset on an Ethereum-based chain. So who can do this? Only centralized exchanges can do this, right? And as we go back to what we described. But these DeFi applications, want to continue expanding, reaching more users, getting more distribution and liquidity. And so this is a simple example where you can host this application on one of these chains and then connect with interoperability layers to allow users to swap an arbitrary asset in the ecosystem through your application that may be hosted on a specific particular chain. And so I think that's, one example we can continue thinking about them. Like another one is, for instance, NFT transfers, right? So NFT has been issued a lot over the last year, but many people want to see applications around them. For instance, I want to take a loan against my piece of art. If my art and NFT representation of it was minted on one chain, but the application where I want to take a loan against it lives on a different chain, like I can't do this, right? Like I can't even go to a centralized exchange, because what do? I sell my art so I can take some other asset. I want to keep my art and I want to take an asset from a different chain. So kind of centralized exchanges don't work at all in this case. And so through connecting the chains directly through a decentralized protocol, you can allow users to still keep their art, take a loan against it, lock it in some application on a different chain, take an asset in return and use it somewhere else and kind of continue from there.
That's interesting. I didn't quite understand that even simply exchanging could have benefits of being decentralized. So I guess the idea is a centralized exchange could be a single commercial entity that could decide to change the rules or to take it down, or maybe an attacker or something takes it down or it gets hacked. Are those kind of some of the concerns that people have with centralized exchanges?
I mean, I think those are some of the concerns, but at the very core of it, I think kind of a decentralized open stack allows people to continue, innovating and reaching audiences that centralized stacks cannot do on the very core, right? So, if there is a new algorithm that you want to experiment with, if there is a new type of a way of an exchange that you want to experiment with, you can take a look at other people's code. You can take a look at, other people's data. You can understand what they've done. You can understand how they've kind of captured users. You can replicate it in a similar environment, in a similar decentralized stack, and get a distribution from all of these blockchains from day one, right? Like centralized exchanges don't have those things. They're bound by, an entity, a jurisdiction, right, and an operator behind them that's responsible for the distribution. And I think just the power of building around open systems actually allows you to go much faster and innovate much faster, where I can keep on building on your work, you can keep on building on my work, we can keep on improving things, we can reach all of the users, same user base, right? All the systems are open. So it becomes a question of who has a better product, as opposed to, who has spent more on marketing, right, and like satisfying regulatory regimes and figuring out like how to create another partnership with another like provider.
Yeah, I can see that. How about one more application that's, I wouldn't say not financial, but maybe less, purely financial? Is there any other that come to mind that are maybe not possible today, but you could see happening? I'm just trying to frame the benefits of interoperability for people that maybe are not clear exactly.
Yeah, so I think one example with blockchains such as Filecoin. So I know for those of you that are not familiar, Filecoin and IPFS are decentralized blockchains and systems that were built to store information and knowledge in a LAN forever, effectively, right? So you can think of it as an immutable ledger where you can write lots of data and people kind of host their websites on it. People kind of host their, NFTs, music, arts, and so on and so forth, right? So it's the ledger that has been optimized to store, I think as they call like a human's most important information, right? So it's an archive of information. On its own, that ledger right now, in some sense, kind of lives in an isolated system, right? And there are APIs to interact with it, and there are ways to connect with it, but you can't really build, interesting applications around that data as of, right now. And so by connecting this chain that has been designed around a specific use case in mind with other chains that have, programmability, for instance, right, we can continue expanding, interesting applications around it, right? So maybe you can host, a social distribution application on one chain. You can connect it with something like IPFS or Filecoin on another chain. You can read data from it. You can write data back to it. And so then you get to interact with these two different environments that have been optimized for different use cases. One is for file storage, another one for programmability, and you can compose them together.
Timescale DB from your friends at Timescale is the leading open source relational database with support for time series data. Time series data is timestamped so you can measure how a system is changing. Time series data is relentless and requires a database like Timescale DB with speed and petabyte scale. Timescale DB is the Postgres you know and love with time series superpowers. Familiarity, flexibility, speed. That's Timescale. Visit them today at tsdb.co/SEradio. That's tsdb.co/SEradio.
That's really interesting. So I can imagine instead of evolving, one blockchain to rule them all that has every capability, we could tie them together and mix and match. You mentioned IPFS. I think that's the Interplanetary File System. Is that what it stands for?
Exactly. Yeah.
Yeah, that's an ambitious project, but I think it makes sense. So I guess that leads to like a question, which is, how big are these blockchains in terms of data? So like the blockchain is a chain of immutable blocks, and the validators in some cases have to download the whole history. Is that becoming an obstacle? Is that sort of just happen to be a size that validators can download, or where is that all heading?
Yeah. Most of the blockchains, you have multiple modes of operation, right? You can run sort of an archival node that stores all of the data that has ever been produced by this chain. You can run sort of a full node, and you can think of it a full node as a node that stores enough data to be able to validate transactions on the latest state of the system, but nothing old, right? So if there is a transaction that happened in the past that's no longer relevant, I don't necessarily need to store it because it cannot be double spent, it cannot be executed again, and I'm not in the business of storing old and archival data, right? So in that case, it's a full node. It's typically like a fraction of the archival nodes in terms of size. So maybe we're talking about depending on the chain from tens of gigabytes to maybe hundreds of gigabytes of data, but it's only sort of the active state of the database. You also have modes of operation such as light clients, right? So on light clients are even lighter objects. Maybe they only store a couple gigabytes or even less, and they only store information relevant to them. So if I want to monitor a specific account and I want to understand what transactions are happening from this account, I can do that. Or I can talk to another full node and ask them for some information, or I can talk to an archival node and ask them for a state of an archival transaction. So you have these different modes of operation, right? And the store requirements, of course, differ. If you want to be an archival node, that's the heaviest. If you want to have a light node, that's the lightest. That being said, I want to mention that there are techniques to reduce storage as well, right, in all of the blockchain systems. So I think proof systems or like zero knowledge proof systems and protocols like Mina, I think are some examples that applying more advanced kind of cryptographic protocols in order to compactify the state and compactify the information so that it can be validated more efficiently, and nodes, don't have to store hundreds of gigabytes. They can store only a couple, actually megabytes of data or even kilobytes of data in order to validate state transition. So all of those things are possible. It's just a question of how and when we get there.
Yeah, I mean, that really rings true with sort of how active the space is, how much experimentation is going on, how quickly things are evolving. So whenever you see a problem that looks like it's going to be a limitation or sort of a hard stop and it's going to halt progress, it seems like there's people that are working around it or discovering new techniques. So that's an interesting aspect of the space. So getting into interoperability a little more specifically, let's first talk about some existing methods. Again, like with the layers, I don't think we need to go into them all, but I'm just going to list off some, and maybe you can pick ones that particularly are good at contrasting with Axelar's approach, or that Axelar did build on, or just trying to frame what are the possibilities here. So we talked about centralized exchanges already as a form of interoperability. There's something I've read about side chains, wrapped assets, token bridges, federated oracles. Just kind of paint the picture of, I guess, what led up to Axelar and what methods are being developed in parallel, or just give us some idea.
Yeah, so I think effectively what happened in the ecosystem is the following. We had, early examples of blockchain, Bitcoin, Ethereum, right? Like 2013, 2015, interesting applications. Then 2017 to 2020, all of these other chains have been built, right? Many of them optimized for different consensus protocols and so on and so forth. What has happened in parallel in there is that people realize that interoperability is going to be an important topic, right? And so some early examples of interoperability are projects like Cosmos or Polkadot that talk about interoperability within their own ecosystems, right? So I call it sort of consensus-dependent interoperability. So meaning that they have designed protocols that have their notion of sort of side chains or chains that can talk to each other through the protocol that's kind of native to the underlying consensus. So that works fine, but those protocols do not scale and don't work to connect with other ecosystems, right? So if another chain doesn't have the same protocol baked in at the consensus layer, it's very hard to connect and interact with it. And so then the last year, we saw an array of all of those solutions that you mentioned, like from, token bridges, like federated oracles and so on and so forth. And the issue with all of them is they're actually centralized parties that are solving the interoperability, right? So just like centralized exchange can allow you to swap one asset to another, you can build a centralized database that allows people to take their token, wrap it in some other form and move it on another chain, its representation. But in this process, because there is a centralized party that you're relying on, we're adding A, a lot of friction in this process, B, a lot of trust assumptions. So if this centralized party that moved the asset kind of goes down or gets shut down or has a quality of service issues, then the representation of the asset that you obtain on a different chain can no longer be moved anywhere else, right? Like you're kind of stuck with it, so you're pretty much losing it. And finally, they don't allow for composability of applications, right? Like as we talked about earlier, if you have an application on chain A and you have an application on chain B, how do you allow them to talk to one another, right? Well, if you're talking to a centralized party on the back end, well, might as well just build a centralized database and a centralized application. It doesn't make sense. And so this is where kind of the world that we were stuck in over the last year. And now that kind of the way we approached Axelar and the way we've designed the stack is to satisfy a couple core properties. One, keep it decentralized from day one. So it's an open consensus. It's an open system where anybody can join and run a validator. You can run a node. If our validators go down, there's a state. You can take it. You can run your own validator, right? And kind of continue working with the data itself. Two, make it easier to create connections with different ecosystems. So just like we have, consensus-specific protocols and centralized parties can actually integrate with them, we want to have a similar property where a decentralized system can understand multiple consensus protocols and interact with them. So that was the second property. And the third one is a kind of a general programmability and composability that we're talking about, right? Allowing different message requests to pass through the network and allowing developers to customize what those messages that they want to pass, right? So we talked about, 3 use cases today. But if you have, 4th, 5th, 10th, 100th use case, we still want to be able to support it. And, you shouldn't have to go and ask us, well, could you deploy this protocol? Could you do this for me? Like, no, it's an open system. It's an open programming environment where people come in and code and kind of continue passing the data as they want through the system and not have to rely on a kind of centralized operator behind the scenes.
Okay, let's get into some specifics about your solution. So we talked about analogies with internet. I think one of your pieces of technology is this cross-chain gateway protocol, which you draw an analogy with BGP, which is the border gateway protocol used by internet routers. Can you explain the analogy a little more and also just dig into what this cross-chain gateway protocol is like?
Yeah, so I think on a high level, for those that are familiar with protocols like BGP, like those protocols at the very core are responsible for connecting multiple autonomous networks, right, and being able to route information and deliver information from them in one shape or form. And so they're actually fundamental. And I think a good example you could actually see from a couple months ago when Facebook misconfigured their BGP routes. Right. And what had ended up happening, like the whole Facebook network and like applications like WhatsApp were just disconnected from the rest of the world. Right. And so that's exactly, a use case for a BGP protocol where its network, however it was configured, was talking with the rest of the world and other networks. And BGP was a protocol that made those kind of translations and connections in the process. And so Axelar as a network, you can think of it as a similar type of, routing layer, right, that underneath it has certain functionalities that allow you to configure these routes across different chains. So you can come in and you can say, okay, I want to make a connection to this ecosystem A. I want to make a connection to this ecosystem B. Here's the path that's going to, happen from a chain A to a chain B. And along that path, the assets or the information can flow. Right. So, and then kind of our cross-chain gateway protocol is simply, a set of commands and a set of APIs and a set of kind of standard transactions that we expose that will allow to configure all of these different rules and make these new connections across different ecosystems, and our overlay network underneath it will support these functionalities.
That's interesting. So are you saying that there actually could be interoperability paths that go through multiple chains, and sort of how many chains might be possible? Or is it a question of finding a sort of a point-to-point connection?
Yeah, so I think it's an interesting question. And I think the answer is that I don't know how it's going to shape out. And I think we'll see, right? If you look at the, history of kind of the internet again, then you have, hundreds of thousands of networks, right? That's mostly, you have to go through like 6 or 7 hops to go from a source to a destination, right? Those are like the averages. In the blockchain systems, that becomes a little bit trickier because even though you can technically go through multiple hops, every hop that you take along the way, you're going to have to take some trust assumptions in the process, right? Because if I go through your network and I rely for your network to verify information and relay it to some other network, then I'm trusting your network, I'm trusting my network, I'm trusting the destination network, and so on and so forth, right? So the more hops that you add, in some sense, the more trust assumptions that you have to make. So that's why I think one of the things that we're starting to see is, Axelar or like Cosmos hubs, they're effectively serving as this universal routing networks, right, that have a trust, underneath it, but then they connect with many other ecosystems. And then, you only need to trust that a single network to go from A to B, as opposed to having to trust, 3 or 4 different networks if there are pairwise connections in this process. How it's going to continue shaping out, I think we'll see. It's an interesting question because the properties, this is where the properties of the blockchain networks and the internet start diverging a little bit, right? On the internet, the network on itself is unreliable, right? And there are no security properties from packet delivery for the most part, right? You tell me the packet, I have to build another application layer protocol on top of it to verify that packet. But in blockchain, we at the very core want to have this verifiability and authenticity property. And so that's why having these kind of hubs in the middle between all of these different ecosystems makes a lot more sense.
Okay, and a second protocol, I think this was mentioned in your white paper, I think that might be where I'm getting this, was this cross-chain transfer protocol. So if the gateway protocol is going to find a path between 2 blockchains, or a path, between 2 blockchains, this cross-chain transfer protocol is going to actually transfer the token or the contract or the asset, or what's it going to transfer?
Yeah, so the gateway protocol is a kind of a network layer protocol that responsible for executing the message and delivering from one source to a destination and executing along the path. And the transfer protocol is more, you can think of it as an application layer protocol that allows developers to, write a message on the source chain in a specific format to an underlying gateway. And then the cross-chain sort of gateway protocol will take that message, route it, deliver it to the destination chain, understand how it has been executed, and call the receiving application on the destination chain, right? So the transfer protocol is, you can think of it as a layer above the network layer that makes it easy for the applications to interact and benefit from all of this cross-chain infrastructure.
Okay, one term I saw, I'm not sure if it's totally related to this, was a threshold account. Is that something to do with this transfer?
Yeah, so whenever you execute in kind of cross-chain functionality, you have to do two types of requests. You have to process like read requests and write requests, right? So I need to be able to read from a source chain A, and I need to be able to write on a source chain B, right? So read requests, they're somewhat straightforward to do. Like you can call a node of the chain, and then you have to have a kind of consensus or a majority of people that are calling all those different nodes and finalizing transactions. For the write request, you have to allow, a set of validators or a set of parties in order to collectively authorize write operations on the destination chain, right? And you can execute those things in multiple ways, threshold cryptography, multi-signatures, various like proof systems. There are all examples that can enable you with the write functionality that effectively says that if you have, let's say, 100 validators, a majority of them or some subset of them need to collectively authorize a message or sign a message in order for that message to be valid on another account or another destination chain, right? So threshold cryptography, multi-party cryptography, and multi-signatures, they're all examples of protocols that can allow people to collectively authorize a decision.
Okay, and you mentioned that low-level internet protocols don't typically have anything to do with security or any promises of security, but obviously with blockchain dealing with financial assets, it's a big concern. So I saw it broken out into these terms: trust, high safety, high liveness. I guess decentralized trust, high safety, high liveness. Are those three different things that are worth teasing apart, or it's just all security?
There are, I think, worth teasing apart, right? Because I think security is so generic that in some sense it doesn't mean anything, right? Until you know what it means. So yeah, I think those three kind of decentralized security is, I think, something we talked about already, which is a property of, not having to trust a single operator and having a protocol and a kind of system that can be supported by anybody, right, in the community. So that's a decentralized property. Safety and liveness, those are core properties of consensus mechanisms, right? So liveness says, under what conditions is my system going to continue making progress, right? How many nodes do you have to participate in the protocol? How many, if the protocol like aborts, how do we resume it? And so on and so forth. And then safety is, again, a core property of any blockchain system that's what allows us to trust it, right? So meaning that it allows us to verify that a block of transaction or a specific transaction is valid according to the rules of the consensus protocol, right? Even in the presence of malicious actors. And this is what traditional distributed systems don't have, right? If there's a single like malicious actor in a traditional decentralized system, they can typically, corrupt data of many other parties and nobody will notice it. But in a blockchain system, that's what kind of prevents some of these properties, is that some malicious validators cannot cause harm in the system and like affect other people to take a different ground truth as the verifiable information. That just cannot happen.
Okay. So is Axelar a delegated proof of stake mechanism? Is that the consensus mechanism or is that the incentive mechanism?
It's more so of an incentive mechanism, right? So how do you run a consensus across validators? And that's what's called, delegated proof of stake consensus, similar to projects like Cosmos or Polkadot, where users that have a certain token that have voting power in the system, they can delegate this voting power to operators that are running, full nodes and participating in the consensus. And those validators then kind of serve in the consensus on behalf of the users with their voting power, right? So delegation is this process of users simply delegating their voting power to another validator that guarantees a certain uptime for everybody else in the system.
Okay, so how many delegates are there? Does this fluctuate over time, and how are they selected? Just trying to give an idea of sort of the dynamic runtime aspect here, like what's kind of really going on.
Yeah, I mean, how are they selected? They're selected based on the voting power that users delegate to them, right? So everybody chooses who they want to delegate their stake to, and then you can say, well, let me take, the first 50 validators, and those are the validators that are going to run consensus, or you can take, first 100 or first 200. And, it is a parameter in the system, but it's a parameter that gets adjusted and will be adjusted depending on scalability and kind of other constraints that we're seeing on the network. I think for us, we're going to start with something like 50 validators, but it's a kind of tunable parameter in the system that you can keep on increasing as you need to.
So would it be correct to say that Axelar is a blockchain, or it has a blockchain, or it uses a blockchain? What's kind of the relationship there?
Yeah, I mean, Axelar network uses consensus and blockchain in order to process cross-chain transactions, right? So,
okay, that makes sense. And I guess I came across another term here was read-write oracle. Is that fair characterization of how Axelar works, or is that something else?
Yeah, no, I think that's a fair characterization, right? Kind of for an application to talk with other ecosystems, you need to support, read requests and write requests, right? So in this case, you can think of Axelar as, this protocol in a network that you can ask to pull the information or write information on your behalf, and the network processes it under the hood.
Okay, you mentioned Cosmos and Polkadot a few times. Are these things Axelar would have to interoperate with, or are you trying to replace them in some form, or what's the relationship between these different projects?
Yeah, we're interoperating across them, right? So actually, Axelar Stack was built around kind of Cosmos SDK, which kind of going back to your question earlier about the programmability is what allowed us to program the network layer itself, right? So we have to customize the validators, customize the logic that they're executing. And so we build around the Cosmos SDK. And through our protocols, we can connect with both Polkadot ecosystems as well as other ecosystems. We also supporting kind of Cosmos native interoperability protocols like IBC, and doing kind of translation in the middle between that protocol and our protocol to talk with Polkadot. So yeah, through Axelar, those ecosystems effectively now become interconnected.
Okay. How about Axelar, the project and the company? Is it a standard venture-backed company, or will any part of the governance itself be distributed through a distributed autonomous organization or some other mechanism? Just trying to understand the relationship between the company and the project, I guess.
Yeah, I mean, there's a, kind of an Axelar company that's building an initial implementation of the software and the protocol, right? That being said, the network itself and the governance around it is going to be decentralized and open down the line. It has a similar upgrade protocol like other proof of stake networks have, like built around Cosmos SDK, where a community can propose a change. If that change is implemented by either our software development team or some other development teams, that change can be adopted in the consensus or in the rules. New integrations can be made, and so on and so forth. And yeah, users can participate in the governance, propose upgrades, propose changes to the parameters like numbers of validators, rewards, and so on and so forth. I think we're definitely going to be continuing to contribute, but it is an open system, and that's what makes it really scale, is the fact that anybody can contribute and anybody can build around it.
Okay, we're kind of starting to wrap up, but what are some milestones coming up for Axelar, either the protocol or the company in 2022? Like, what do you see as some of your goals?
Yeah, we're continuing to scale actively and starting to actually deploy our network on the mainnet, right? So I think a couple of weeks ago, we announced that we're starting the rollout of the network. So that means we're starting, we built initial connections across half a dozen of ecosystems. First use cases and kind of asset transfer applications and similar ones are starting to go live. And we're going to continue turning on the network over the next 4-6 months, gradually turning on various functionalities that we've been working on, onboarding ecosystem tools like validators, developers, dashboards. And really the next years for us will be, how do we take every application and allow it to go cross-chain and allow it to go multi-chain, right? And so we're going to work closely with our developer community, with different applications on different platforms, to give them this capability over the next year. And alongside with it, we'll be building on the back end and kind of supporting all the infrastructure.
Okay, we'll talk about how people can find out more in a second. But taking a step back, what developments are you monitoring for blockchain in general this year that would impact Axelar and interoperability, sort of what's happening in the space that you're tracking?
We're always tracking of, new interest in ecosystems, new interest in applications, and new interest in use cases, right? So some chains are being recently launched. Some chains are going to launch over the coming months or weeks. Different applications are being built around those. And so we're keeping a close eye and, figuring out where we can help those applications or those chains go global in some sense. And that's what a primary driver of how we think about our development and our roadmap is.
Okay. A lot of companies and startups, they say that the founders started them to solve a particular problem that was personal to them. If interoperability continues to become more robust and more fluid and easier for users, what personally are you most looking forward to as an application that you'd like to see available?
I think to me, an ability to just frictionlessly transact and go across multiple ecosystems is what I would like to see, right? I think, as a personal example, I think I onboarded a friend to a blockchain ecosystem and I told him go use this wallet, go use this application. And he started playing with it. He started generating hundreds of transactions on one chain. It was great. And I became, a liquidity provider. I've never even heard that term before, right? Now I'm a liquidity provider. Where could I provide liquidity for my $10, right? In traditional finance, that's impossible, right? You take your $10 and you can't do anything with it. And so just seeing regular audience and folks that are not familiar with the blockchain, unlocking this different kind of a use cases and the power of decentralized finance and other open systems, I think it's super powerful. At the same time, this friend saw another application on Ethereum and he started to use some bridges and then we lost him, right? And then he realized that once he gets to Ethereum, he has to pay, $300 in transaction fee. His transfer was stuck and he couldn't get out. So that's how we lost him. And I don't want to see that. I think I want to continue onboarding, regular users that can understand the power of these applications, give them new opportunities that they could not have behind traditional closed systems, and see them build their own use cases around those.
Yeah, I've heard about the fees can get pretty significant in some cases. So one question is, if Axelar was created to work with some blockchains that perhaps were designed long before Axelar existed, going forward, how do you see new blockchains? How would they be developed to work with interoperability from day one? What kind of changes now that interoperability is a thing for future blockchains?
Yeah, so we have done two things. I think one, we have an arbitrary support for common software stacks. So meaning that if your chain supports Ethereum virtual machine or Solidity, you actually don't need to do anything to integrate with Axelar. Okay, so it's 10 commands will run through the network, or you can run, and then you can integrate your chain. You can optimize your consensus, kind of governance rules. And in that case, we're sort of agnostic, right? So we integrate at the software programming interface. If that's not available for you, then at the network layer, we have really built these kind of core primitives that you need to make other connections simpler that you can leverage, right? And that comes down to those read functionalities, those write functionalities, and those cross-chain process and translation functionalities. And so at the network layer, we have built those where if you have a very custom environment and so on and so forth, you want to integrate with, you can reuse those building blocks and write your own translation layer to integrate your blockchain with all other ecosystems. And what we have done is exposing those building blocks and functionalities that are needed for interoperability at the very core.
Yeah, that's where you can really see how things evolve, where you're building on everything that came before. But if you're adding significant new capability, then the next person is building upon that.
Kolide sends employees important, timely, and relevant security recommendations for their Linux, Mac, and Windows devices right inside Slack. Kolide is perfect for organizations that want to move beyond a traditional lockdown model to one where employees are educated about security and device management while they're fixing important problems. Visit kolide.com/SERadio to sign up today. That's KOLIDE.com/SERadio. Enter your email when prompted to receive your free Kolide gift bundle after trial activation. You can try Kolide with all its features on an unlimited number of devices for free for 14 days. No credit card required. Try it out at kolide.com/SERadio.
How can listeners learn more about Axelar and blockchain interoperability in general, whether its website or podcast, and I can put this in the show notes so people can see it.
Yeah, I think, to get started, to learn about Axelar, you can visit our website, axelar.network. You can follow us on Twitter, Axelar Core handle. I encourage everybody to sign up for Discord. It's a very vibrant developer community. We have over 30,000 developers that are signed up on it. We have various testnet channels. We have various social community programs where we engage folks to develop content or write their own tutorials around the network or how to use its functionalities. And if you have any questions there, again, feel free to ask. Lots of people that are watching those channels and will help you answer them. And yeah, I think just get engaged, start building. I think that's the best way to learn.
Okay, can I ask the name Axelar? Where does that come from?
Yeah, great question. Well, a big constraint by picking a name is making sure the domain is available. So that was a big factor. But, I think as my co-founder and I, we were thinking through it, where Axelar is a play on words on accelerating the ecosystem, right? So that's a play on words on that.
Okay. And how about you personally? Do you have any social media or blog or anything that people could follow?
Yeah, I think the easiest place to start is to follow me on Twitter. It's Sergey_NOG. From there, you can find a couple links to my website, like some white papers that we wrote over the years, kind of standards and things like that.
Okay, I'll put those in the show notes also. Thanks for your time, Sergey. This is Philip Winston for Software Engineering Radio. Thanks for listening.
Thanks, Philip. It was great being here.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.